Welcome to Square Roots, also known as radicals. That little sign that looks what we call a square root sign is a radical. We're going to look at them with an index of 2. When you have an index of 2, and by the way, what's an index? Well, an index is right here, this 2. Normally, it's invisible. The same way we have invisible ones in front of variables, invisible one exponents, because we don't need them. Math is filled with invisible numbers. We have this radical. It's a square radical sign, which means square root. We have something called a perfect square. The square root of 36 equals 6. It is a perfect square because the answer is a whole number. Here are some examples of perfect squares. 4, 16, 25, 36. If it's not perfect, then you must round it. And normally and often, these rounded values are irrational. So you need to decide, am I going to round it to the 10th place? Am I going to round it to the 100th place? And of course, this takes into effect that you understand rounding. If I say round to the 10th place, I underlined the 10th place value, 8. Look to the right. Does 3 stay the same or go up? Hint, 5 says go up. Everything else says stay the same. So if I have a 0, 1, 2, 3, or 4, I stay the same. 5, 6, 7, 8, and 9, I go up. My answer, 5.8. Basic square roots. The square root of 64 equals 8. If there is only one answer is needed, then you use a positive 8. The negative or inverse of a square root, if I have an inverse sign in front of my radical, that means I take my answer, the square root of 64, and I make it negative, negative 8. You need to know that there are 2 answers for square roots. You learn this eventually, which is now in 8th grade. The square root of 64 is actually plus or minus 8, because both 8 and negative 8 are true answers. You can assume positive unless you are asked otherwise. That little symbol plus with the minus sign under it means plus or minus. Why is this true? Because 8 times 8 is 64, and negative 8 times negative 8 is also positive 64. We learned that when we did our rules of integers with positive and negative numbers. Square roots of fractions. Well, I have 2 different methods that we can use. I can solve inside the radical first. This works fine if those numbers divide pretty evenly. Or I can take my radical apart and I can do a square root of the numerator divided by square root of the denominator. The only time I want to do number 2, the only time that I want to split it apart is if both the numerator and the denominator are perfect squares. Otherwise, leave it and just solve this fraction first. They both get the same answer. Here I have 16 divided by 4 is 4, square root of 4 is 2. Square root of 16 is 4, square root of 4 is 2, 4 divided by 2 is 2. But if they're not a perfect square, then you're going to just do the inside first. 32 is not a perfect square. Neither is 8. So I'm going to do 32 divided by 8. I get 4. How convenient. It's a perfect square, equals 2. 16 over 25. They're both perfect. Split them apart. You can see why that's easier, because 16 divided by 25, I can't do that in my head. I know it's going to be some big long decimal and I need a calculator for it. But if I split it apart, square root of 16 is 4, square root of 25 is 5. What if I have an expression inside my radical? Well, the square root of 7 plus 18, let's solve it first. It's like parentheses. Solve what's inside the radical first. Square root of 25 equals 5. When the answer is not a rational number, you will need to round it. An assessment will tell you to either round to the nearest tenth, which is your first place value after the decimal. 2 says stay the same. Or round to the nearest hundredth, which is your second place value. I underline the 2. 7 says round up. I'm going to get 5.63. I always underline the place value that I am looking for and then look to the right to determine if you stay the same or go up. Rounding is critical. You have to know how to round. Examples. So the square root of 4 equals 2 and the square root of 4 equals negative 2 because 2 squared equals 4. Negative 2 squared equals 4. Therefore, my answer is written as plus or minus 2. Square root of 121 plus or minus 11. It's either a positive 11 or a negative 11. Both answers are correct. Now, of course, we did tons of this when it came to factoring polynomials and even with quadrilaterals. So this is something that gets you ready for algebra. There's time, but this starts to prepare you. Square root of 81 over 9. I know those are perfect squares. I'm going to pull them apart. Square root of 81 divided by square root of 9. 9 over 3 equals 3. And or negative 3. Because if even one of these was a negative, let's say that this 9 is a negative. A negative divided by a positive is a negative. So I have to realize that anytime you have a square root, you have two answers, a plus or a minus. 12 and 3 are not perfect. I solve what's inside the radical first. Square root of 4 equals plus or minus 2. I am not going to pull it apart because that would be way too difficult. You only split up the radical when the numerator and the denominator are perfect squares like number 11 above. Let's look at some more examples. Square root of 16 plus 9. 4 plus 9 equals 13. But what if it was negative 4? Then it would be negative 4 plus 9. That means my solution is either 13 or 5. Okay, this is a game changer. I have two separate solutions, not just a plus and minus 4. I have to solve. Negative 3 times square root of 81. That means negative 3 times 9 or negative 3 times negative 9. So I have a negative 27 and a positive 27, plus or minus 27. If you are asked for all answers, and if you are at an upper level, which you should be by 8th grade and freshman year, you need to know how to do both answers. Square root of 31 plus 5, square root of 36, this was simple, plus or minus 6. Here I give you the rules on a calculator. So if you happen to have the TI-30XA, there are your directions compared to a TI-34. 9 times, I'm not going to read these all out loud. I want you to look at them so you know which calculator you have. And if you try to do the square root of 9, you determine which buttons you press. The cubed root of 27, which we haven't even gotten to yet, but this tells you in a calculator how to get to it. The fourth root, fourth root of 81. This means what number multiplied by itself 4 times equals 81. But this is coming in another set of slides when we get to irrationals and fractions. But for now, here is the way that you use your calculator. Bye now.